Hello, so now we're going to be starting the integration topic. Now, integration is a really interesting topic, probably gets a lot less love than differentiation, but still very interesting. So let me crack on. So, first thing you hear when someone says integration is you hear someone say, area under a curve. What is integration? It's the area under a curve. And I'm thinking, why do I even care about the area under a curve? Seems pretty boring to me. It seems not that interesting. Why would I ever want to do this? And it's just underselling integration. It's really much more interesting part of maths than areas under curves, but that's what often comes up in questions. So what have I said here? Yeah, integration being described as finding the area under curve is a bit like saying, yes, multiplication. We use that for finding the area of triangles. That's the only reason multiplication exists, which basically, as you know, is not the case. There are lots of interesting stuff you can do with multiplication. So what I'm going to try to do here is build out some intuition for the area of a curve. The area of a curve for integration. Okay, so what we're first going to do is start that by building an intuition for what multiplication is. You might think, okay, multiplication, that's quite simple. I've mastered that. But really, you'll understand that a lot of complicated maths is just simple maths that's been jazzed up a little bit. So let's go through and have a look at trying to understand what multiplication actually is. So if I say here, what's this question? It's 2 plus 2 plus 2 plus 2. Okay, so that's 4 plus 4, which is 8. Okay, so I'm saying that's 8, right? But what is this? I'm saying 2 4 times is also 8. Okay, so it's the same question, just asked in a different way. It's just applying one number to another number, right? Pretty straightforward. I hope you're all still with me. What about now? So what would the area of this triangle be? Assuming that you can see here that this is one unit, that's one unit. Okay, so you could go, okay, well, 1 plus 1 plus 1, okay, all the way up to the final answer. Or you could see, okay, well, it's 4 long and 3 deep, so 3 times 4 is going to be 12, right? So it's 12, 3 times 4 is equal to 12 units squared. Awesome. Okay, so what about if this wasn't if this was just, I asked you this question, okay, what's 3 times negative 4? Okay, well, that's going to be negative 12. Well, that's exactly the same question, except you've changed one of the negatives. But obviously, you can't have negative area. So are you saying multiplication is just for area? Because multiplication works here, and we know that we can't have negative area. We can't have something that's negatively spaced out. It just doesn't make sense. So yeah, again, just looking at multiplication as a way to find area doesn't work out. Okay, well, what about this? All right, so what about this area here where everything's not completely equal? How would we figure this out? Well, you could use just addition, which is, if you take this as 3 times 1, so you could take that as 3 times 1, which would be 3. So that'd be 3, 3, 3, okay? So, and then you have this last one here, which is 3 times 0.5, so this would be 1.5. So this would be 3 plus 3 plus 3 plus 3 plus 0 plus 1.5 even. That's 1.5, which is going to give you 13.5. Okay? So you're adding up all these individual chunks to give you this answer. Okay? So what I said here, we combine the 3 and the 4 whole bits to give you 12, and then you combine this little partial bit here to get you the 1.5. So what we've done is we've split this up into more manageable little bits and then added them up, okay? And that's basically the idea of integration, okay? I know you're thinking, well, it's so obvious just to do 3 times 4.5. It just makes sense, okay? It's just going to be 13.5. It's not a complicated equation. Why make it more difficult than it needs to be, okay? Well, the thing is, what if this distance, this 1 or 0.5, was changing all the time, okay? Then it would make it really hard to multiply this out in one step, right? So I'm going to stop this video now and start a next one so these don't get too long, and we're going to explore that idea a little bit more.